Hi everyone, today I'm going to discuss with you about what is the KissOps principle or the unexpected virtue of delivering business value to our end users. So, KissOps principle, it is about. Of course, KISS means in popular definitions, keep it simple and stupid. When we merge that principle, that KISS definition, keep it simple and stupid, to DevOps or DevSecOps or XOps. Um, it stands for having a mindset where we want to keep it simple and stupid. So it's not not complicated here. Um, what is the rules apply to being KissOps? Uh, no compromise on infrastructure as code, configuration as code, and security as code. In short, we need to have everything as code. Simple as that. We deliver via pull request and automated pipeline with approvals, so no manual intervention. Everything is shown when change happen or need to be deployed. All applications are containerized. Is the most important thing, that everything we need to deliver, every business application we need to deliver need to be containerized. Everything is always fully operationalized before being shipped outside the dev environments. This one is a rule really important. In fact, every rules are important, but we tend to not deploy outside dev if it's not operationalized. I have a YouTube video about the operationalization. So in short, if it's not operationalized or if there are points that are missing for the operationalization, we don't ship it outside the dev because it's that. Keep it simple. Documentation are not allowed. That one can maybe be curious, but we tend to, because documentation normally in some organization tends to be written one time and then never being updated. So we replace the documentation by something that is more living. It's a tool that we define as part of the repo, where we have application, where we have stuff that are automated in Git repository. So we tend to not read route documentation in Confluence or stuff like that. We tend to keep it with the repo with the Markdown file. So it's kind of a living documentation we need to integrate in the principle. And rule number 6: simplicity. It's simplicity. So we're gonna see it later. Why and how? To apply the KissOps principle, we need to have one simple and normalized process delivering business value. I mean about that. It's across different software application we deploy, we create. We need to don't have different ways of working, because ITs is not, how I can say that, our customer, our end user, we work for our end user. So we're trying to keep it simple as possible because we want to enable the business value that we deliver to our end user the fastest ways possible. So having something normalized will remove the complexity of delivering our software. So that way we can ship end user business values faster than having something different or cannibalized. Tool and product that are native or offer easy integration. What it means is we tend to stick with the product we have without having too much vendor integration like Kubernetes. I know there's a lot of vendors product around Kubernetes to do mainly also there is very popular, but there are a lot of DevOps tooling around Kubernetes. It's cool, but it's not because it exists you need to use it. It's not because it exists that it fits with your process. If you don't need it, don't use it. If you don't understand it, don't use it. So you need to be really careful with tool integration with your infrastructure, because if you don't need it, don't use it, and it tends to over complexify the delivery process, because sometimes you can be stuck because the vendor is not aligned with your upgrade that you have planned, and then you're stuck in the loop where at the end the end user don't have his business value that he is paying for. Everyone can give us an on every projects and teams. Again, because everything has been normalized, you can pick a developer from one team and goes on another team, and it doesn't need to relearn everything in order to deliver his features. Over time, it reduces costs required to deliver business value. Why? Because you don't need you don't lose time. So losing time means paying someone to do something that is different. So over time, it reduces the stress more and increase the confidence in your delivery. One simple normalized process delivering. So I took each point one by one. So one simple in details, one simple and normalized process of delivering business value. So again, the key here is the containerization. Build a container image is easy. Deploying container image is easy. Also easy. So no matter if the application is coming in different language, it can be a Java application, a .NET application, a stupid PowerShell script that you need to deploy to do some cron job. No matter the technology you use, the coding language you use, it's still a container. So from that point, it's super easy to build it from the pipeline and release it from another pipeline that release it with Helm, by example. So from that point, it's simple. And we're gonna see it later. Tools, products that are native and easy integration, I speak a little bit previously. The more native and simpler you are, the more simpler. It's simpler to learn by everyone. Simpler to integrate, simpler to evolve over time, and simple to support. So when you have, by example, Kubernetes, in the past I was tending to say that it's hard to learn. It's not hard to learn. There's a lot of stuff that you need to know before going in Kubernetes, but once you know those principles, those kind of ways of working, like reverse proxy, NGX stuff, deployment, what is a container, and so on. So once you know everything about those kind of things separately because you've done it before in other platform, it's simple to learn. But what it can be hard to learn over time and give some edge. It's the product that you put in place in your Kubernetes cluster and in your Kubernetes infrastructure, because you're relying on something that is outside the basic knowledge of the technology you use, and you need to dig a little bit more because, okay, that plugin, that vendor product is working like this. Oh, that other product working differently, but it's kind of the same feature that we have. So over time, it can become complex, or how can I say, more consuming over time. So having something simpler will normally increase your cost efficiency because your effort will be stick to something that is more standard across your infrastructure. Yes, everyone can give their hand. So they know superhero here with the KissOps principle. We don't have one people that can do everything for everyone. So everyone can give the hand. So let's go with the responsibility of each team. We're gonna have developer and QA teams, case engineer and SRE engineer, site reliability engineer. So let's go with the developers and QA responsibility. Basically, each day, developer and QA develop and test what the business value that the end user requests to them. Simple as that. So they don't have to code the pipeline. They don't have to think about the pipeline, how to build and how to deploy on the Kubernetes cluster. By example, I use the Kubernetes technology as an example because I'm using it. It can be other container orchestrator. We don't mind. It's a principle presentation. So the advantage is the developer and QA concentrate on what they do best, code and test. Context switching, they all need to understand the business domain. If they change from team A to team B, they only need to understand what is the new business domain that the business domain they need to learn. They don't have to care about learning a new way of building and how the CICD are done. They don't have to do that. They simply have to stick to the business domain they need to code. Simpler to run locally, everything is containerized. Yes, that's a point interesting. It's because everything is containerized, they can build it on their machine, they run it the same way it will be in dev and prod and test. So that's really important because developer team tends to say, okay, it works on my machine, but it don't work in dev, it don't work in QA, and it doesn't work in production. So having a containerized approach will give the ability to, okay, if there are business domain bugs in the code, it won't work. If it doesn't work on the dev machine, it doesn't work on the other environment, which tend to be different once you don't have a containerized delivery process, because the mistake can be done manually. And dev is dev, so, and ops it's ops too, so there's a constant battle about that point. So with a containerized approach, it's way simpler to remove, to don't have those battles. Responsible and autonomous for the deployment from dev to prod, that's another point. We tend to have a developer team to be able to deploy from dev to production, not without gating for sure, but they are, because it's them that does the business, that create the business value. They code it, so we make them responsible to deliver it. So they will understand what's the delivery approach, the delivery process, but they will make the deployment and production. So the KISS engineer, so we are KISS engineer are the platform gatekeeper, and they review what the infrastructure and project architecture choice are making. Why it's not the contrary? It's because when we have when we want to standardize the infrastructure technologies, we want to also standardize the way we're gonna deliver. If we have multiple technology in the stacks, that means we're gonna have cannibalized delivery process, which we don't want, and we're gonna have cannibalized kind of developer project too. So we stick to what has been approved and decide by the KISS engineer. Let's say by example, if we decide for project A to use SQL Server and MySQL for another project. So totally the database technology is totally different, so the delivery process will gonna be a little bit different. So we want to avoid that situation. It's why it's one technology and some technology is decided by the KISS engineer. So the advantage is the onboarding is easier. We have one way of building and deploying business values to our end user. So in that point, at some regard, we're gonna see it later, but we have one base script to deploy almost every kind of project. And the minimal, we have a minimal stack technology that are mastered by everyone in the team. So let's speak about SRE. It's all about operation. So their job is to ensure that everything is run smoothly and correctly. So the advantage is it's going to be easier to support for them because faster problem solving, limited warring, and deploy fix the same way as developer and QA team member. So for the first three bullet, SRE team, when an outage will happen in production, they're going to know what to do. Even for the project A or the project B, they're going to be able to see what's going on for those projects the same way they do for each other project. So there's no difference in each. So there's nothing more bad than having documentation it's somewhere and done differently than the other. So there's no question about it. So they can resolve the problem faster. If they need to change code that has been made by the developer and QA, because in some organization it's happened that it's frequent that SRE engineers are making small change, so they're gonna use the same application repository in Git to make their change. So they're gonna do a branch, not fixed branch, then do a pull request, then it's gonna go with the approval process, and then it will be deployed in production to resolve the issue. So everyone's need to work the same way, and then the advantage of that we're gonna have a trace of that the SRE engineer has fixed a database connection string in production because of some things happened before. The other point is the reduced cost to deliver business value. Again, I tend to repeat myself again, but that's quite important because in organization, right, since we implement at some organization Agile methodology, DevSecOps methodology, we tend to have a creative way of working where we have cannibalized CICD across different applications. So we stop having a standard way to work. We stop losing time with those cannibalized CICD that sometimes are flaky for some reason we don't know, and once a month, each month we're gonna we dig in to understand what's going on. So we stop losing those time. over time when we standardize a way of working. Simple delivery process, less team, less people, shorter and less meeting. Meetings are killing the cost efficiency. So we remove that. Uniform technology use, maintain, and support. Everything has code. Shorter deployment, faster build delivery, business value delivery. Everything has code. Use only what you need. Unused resource doesn't exist. So we start having a pay-as-you-go mindset. That means that if we don't need dev over the weekend or the night, we simply kill it. We simply delete it. Why? Because we don't use it. And why? Because we are everything as code. Each day we automate the process to recreate the universe in dev. Same things for, it can be the same things in tests, and it can be the same things in QA. That's the spirit behind the DevOps approach, the DevOps methodology that has been used by the market since, I guess, 10 years. So that one is, for me, quite important. We have a fully platform and application operationalization, less complexity to support and diagnose, which bring more, which reduce the cost of having an intelligent problem. And because platform and application are operationalized, we monitor the infrastructure cost the same way we monitor the platform and application. Yeah, simple as that. Nothing is complicated here. KissOps also bring less stress and more confidence in what we deliver. Development teams stop losing time with cannibalized CICD Pipeline. Again, the same things I've said in cost efficiency. It's simple to deliver, simpler delivery process, less team, less people, less meeting, less fights. Fights in teams, between teams when outage happen, tends to bring down the efficiency of resolving an issue. And if people that are required to fix the issue are stressed, they can do mistake in production, which bring more problems. I've seen that in the past, and it's not cool. It's not cool. And when we have a war room with 50 people, half of them are management because everything has been stopped because of a stupid change or stupid decision making by stress. It's not helping anyone. Everything has code, shorter deployment plan, yes, cool. More confidence to deliver business value. So the shorter the deployment plan is, because everything has been automated properly. When I say everything is automated, it includes not only the application, but the certificate, the generation, the DNS change, the blue-green kind of sort of deployment, where we can have smoke tests before activating in production. It increases the confidence. Fully platform and operationalization. Again, I tend to be harassing with that, but less complexity to support and diagnose. Again, it increases the confidence, because if you are on call during the weekend, you tend to not check every hour to see if there are problems. You will know over time that if there are a problem, you will receive an email or you will be pinged, because the system has automated alerts in place when problems happen. So the key is, because platform and application are operationalized, we can be more confident to resolve production incident quickly and smoothly. this is the key of having something simple here. So that's it for the slide. Now I'm gonna show you a little bit more about all those concepts. Alright, so let's go in deeper in the hands-on around the KissOps principle. First thing first, Alright, so let's get a little bit more the hands dirty around the KissOps principle. To show it simply, we're gonna deploy a new 1 and 2 new application into the Kubernetes platform have right now. We're gonna see how fast it is to deploy application somewhere. In fact, how fast it is to deploy a new business value. So the first thing first, we need it's right now I don't have my Kubernetes dev environment, so we're gonna create it. Azure, we're gonna go on Azure. I will simply because I want to show you that I'm not cheating. I'm not cheating with you, so I don't have here dev environment. I only have one prod cluster right now. So I'm gonna go on my GitHub, inside my organization. So I have an expected base infrastructure, which is the infrastructure repository I have to deploy my infrastructure. So I'm not cheating with you. So okay, action. I will take the last one I run. So in my infra pipeline, I have as what I have the build to build the Azure Bicep script that validate that everything is fine. I have a foundation stage that does what? That does the foundation. I need to support the development and the production environment. This intend to deploy the DNS zone. So right now, do I have dev DNS zone? Yes, I have dev budget planner, dev expected solution. Okay, so that's okay. And the dev cluster. So most of the time, I don't always redeploy the production. I can, but I don't have any change on it. So I will replay the dev stage, and in 5 minutes we're gonna have a fully operational Kubernetes cluster. I'm gonna wait a little bit. Okay, that's review it. Okay, we're gonna wait. Doesn't take long, maybe 5 minutes. 5 or maximum 9 minutes. So during that time, I'm gonna show you what my company, my organization infrastructure is structured. The idea of having a pipeline like this is give me the ability to also being able to will deploy a brand new Kubernetes cluster with a new updated version when Microsoft Azure decide to bring up a new Kubernetes cluster version that can be available. I don't normally update my own cluster that is on. I simply bring up a new one, and Then, when I need to redeploy on it, I simply rerun the other pipeline, the other application pipeline deployment, and instantaneously my application go there. I don't use I, I don't use GitOps pull pattern. I am using a GitOps push pattern, which is a pipeline that pushing the code, pushing the application inside the infrastructure, not the contrary, where I might have a Kubernetes cluster with an operator that is listening on my GitHub repository. Personally, I don't like that mechanism. I don't like the mechanism putting something on the infrastructure to listen on the repo. Personally, I don't like that. There might be scenario, it's a must, I agree, but in my case, I'm not in that scenario. So, so how I'm organized, I'm organized. In fact, my foundation layer, that we saw here, does what? Deploy the foundation. So, which is in the past, I had the Azure container, which at the time I wrote down that plug and through. So right now it's no longer required, so I don't have it. But I still have Azure Key Vault. It's where I store multiple passwords used across dev and production. It's like password. It's not password. It's key value that I need to use because I have an Azure storage account that I use to back up some stuff. So it's the key that is linked to those storage accounts that are in the Key Vault. And I have Azure DNS that drives out the access from dev and production. So yes, I have a dev DNS for dev.expectasolution.com that rely on expectasolution.com because it's a child root. It's a child zone inside my root zone. Oh, I have that. And then when the foundation is available, then I deploy the dev. So in dev, I also have a key vault for sure because I store secret. I have a secret per environment, so I have it for prod. I have a SQL Server instance in dev, and I have a Kubernetes cluster in it. So the idea here is when I deploy an application, that the application when it's the pipeline when the application pipeline is run to release on dev, the release pipeline pull the secret from the key vault to get the secret, and in those secret we have the instance name of the SQL Server of dev, and we have the cluster name for the dev environment. Because the way we deploy the Kubernetes cluster, we name it with the version number and a prefix number, a prefix letter. So when I deploy back a cluster, if I change the name, it will change the name in the Key Vault, and then the other application will be deployed there. So let's see where it goes. 5 minutes. Okay, I guess it's okay. The dev is been created. It's not. Oh, it's running well. It's fast. So as we see that we have X for Experta. Nothing original here. Dev environment. PRD for prod. I have version 1.25.5. So if I go on the cluster configuration, Oh, we have an upgrade. 1.26 in preview. So later we're gonna switch over. I will show you how I switch over. Okay. I have a prefix A and I have the mention east to west. Right now, my infrastructure is not deployed over multi-region. Okay, we don't have the capability to have a Kubernetes cluster in multiple regions. One cluster with multiple nodes inside across multiple regions. But what I did, and I will show it in other demos, I have the capability if I need. By example, I have a website, I have a platform I developed, which is called budgetplanner.cloud. If, by example, I get more customer across the world, I can bring up Kubernetes cluster in those regions and have the ability to deploy my application in all those regions. So it's why I name my cluster, my Kubernetes cluster with the region name. So right now I'm in East to West. For cost, simply for cost question. So okay, my dev is over. My dev cluster is over. Let me just do a small thing. Oops. So right now I have nothing on it. Yes, I'm using K9s. It's a CLI tool for better accessing the Kubernetes cluster. It's Mozilla and I'm quite lazy right now. GitHub. Okay, I'm going on GitHub and I'm gonna deploy my website. I'm gonna deploy it on dev. Just wait a little bit. Okay. See that later. And of course, my website exploited solution has been operationalized. So when I'm going on exploited ops.exploited solution, I'm seeing what the architecture have, what the access and security I have, what is the industrialization, what is the monitoring I have. So if I want to see the workload of my website, I simply have to go. Oh, I don't have the link. That's cool. Oh no, it's the workload. Okay. I'm going on New Relic because I'm using your New Relic. Go there. I will see what I will see that I have nothing because my website is down. Session back. Sorry for that. And the process is still building. So we see that I have no traffic. So if I look over, thank you. 7 days. Over 7 days, you see that the response, it stopped reporting metrics and monitoring on February 17. So we're gonna see it up again. Okay. Sorry for the noise. My wife is preparing something to eat. Develop development waiting. So I did that. I did the operationalization of my website, my own website. I did that also for the platform automatically by code. How? In fact, in GitHub, we have the capability to create a website from the repo with the markdown file. So it's automatically generated that there. So I keep it as documentation as code, kind of. Okay, get started. We're gonna deploy my organization website first, and then we're gonna create a new website. So everything has been containerized for sure. Maybe you are quite questioning where I store my images. It's simple. I have export a website repo, and I have packages for my website. In Docker Hub, in GitHub, we have the package registry where we can store NuGet packages, npm packages, container image, every kind of package we can store. We can store it there. The only thing that GitHub package doesn't support is the Helm chart packages. So for that, I simply did a simple things. I create a repo called Helm, and I'm pushing my Helm chart there, and I have a build that upgrade an index file. So that way I can use Helm as a package repository manager. I can use Helm with that repo as a Helm package repository manager. So I have a lot of package that I use it. Okay, we see that the website is going now there, and let's go on the export to deployment. It's over, but yeah. So when we say that we have a standardized way to work, it's true. One small thing that we need to change by application is probably more the stuff like the certificate, SSL certificate, and DNS. So in the pipeline script, we simply add it. Simple as that. I'm gonna wait because of the L check is taking a while. So we see that we deployed the version 1.9.0. And I'm gonna put it one step at a time. Okay, the DNS is updating the entry I have for the dev.exploitation. Okay, the site is up. Dev.exploitation is up. So nothing fancy here. Yeah, how it's work, how it works. In fact, let me. Oops, create a branch, features, demo, kiss, KissOps demo. Okay, we're gonna have a look at the pipeline, the release pipeline. So what I have here, my application is not inside app.deployment. My application is inside another repo. That repo expected deployment. The intention is to build the Helm chart used to deploy the application. Okay. So I have what there? I have a chart with a dependency to another chart, which contain the container definition to be deployed inside my Kubernetes cluster. So what we're going to do here, if we want to add another application to be deployed, because normally the expected the deployment repository used to deploy is not accessible from the dev team, because we can have secrets there. We can alternate. We use it to secure secret that we're gonna deploy in Kubernetes, or if we give it to other teams outside the platform team or the platform engineer, or I don't like the name, but the people that deploy it. It can be insecure. Of course, development teams will trigger the deployment, but they will not go there to change infrastructure stuff. So over here I have a config map where that are used by the other application. We have an ingress, we have role bindings, we have roles, we have secrets. Okay. So the release, what it does. Okay. In fact, I'm bad at explaining because there are a lot of things, and I tend to go everywhere. But let's go inside the workflow. Okay, here I have my build. That's okay. I have my development, and my development process. Okay, I do a Docker login for sure, because I need. Why I need to do a Docker login there? Okay, that's weird. That's weird. Okay, but what we see that we have secrets stored in GitHub, and I inject it in the pipeline. I secure my stuff. That's okay. Here, deploy exploitation website. What I do a Docker build of my dev release Docker file, and it's because I containerize also my process, my build and my release process. That's another step forward. So what I have in the dev release .docker file, I have a reference to my development infrastructure release container, which contain environment variables stick to the dev. Okay, organized like this, it can be improved. It's okay, but the idea here is to have something standardized. So everywhere I have a release to dev and prod, it's always the same way. The difference is I include the my credential to go on Azure, the app version, and that's it. The base container contains the logic to do with that, to do the deployment. Also, I inject the release.ps1 because in this container I have base script to achieve the deployment. But the release itself, in fact, I inject the release.ps1. I get the Kubernetes credential, so I get the credential to log on, and from the base I pull the secret from the dev vault, and then I'm able to know what is the target cluster and so on. So the idea here is I simply add the repo, the MIN repo. I pull the dependency I have in my chart over here. So if I put another dependency that I don't have, the deployment, the build will fail simply. So we're gonna add one there after. I tar it. I untar it, the dependency. And then I deploy it. And for the DNS, well, I have a current environment DNS JSON file that is inside the environment container, because I have DNS for dev, DNS for prod, so I'm not including prod DNS inside the dev container. So over here, I simply say, okay, but for point out those DNS record to my Kubernetes IPs. In that website, I don't recreate an ingress, a dedicated IP address. I simply use a unique IP that I use across my Kubernetes for cost saving, because an IP address costs, I guess, $1.25 per month. So I simply choose to not paying for an IP address per application or per project. It's personal, but you do whatever you want. So it's simple as that. So what we're gonna do first, because we want to add a new application, we're gonna have a look at the other application I have. In fact, we're gonna create a new one. Okay, let's create a new project, a new code project. Starter that website. Let's call it new KissOps demo, a private one, create a repository. Yeah. Okay, I have my repo. Add the clone one. Clone it. Can I create a... Okay, Jerry and then... Okay. Okay. Gonna produce something. Okay, I'm gonna create the folder source. And it's going right there. I'm gonna do something simple. What's going on? Oh, JetBrains decide to crash. Okay. Let's create a solution. I'm gonna create a new website, ASP.NET Core website, simple things, no authentication, Docker support disabled. Okay. And as I did every time, I think I did not put it at the right place. Where I put it. Oh god, I did not put it at the right place at all. My bad. Delete it. My bad. Sorry. I put it at the wrong place. Let's see. KissOps. Yeah, that's not the right place at all. Okay. let's run that thing. Okay, let's run that thing. Expo is running, start running. I hate that Angular stuff. Okay, I understand. I was waiting for manual integration. Terminal. Yes. Good. Now it's gonna work. Good, it's working. We have our site, the counter, the home, the fetch data, that everything is okay. So we have an application, a .NET application, not yet containerized, but we have one. Let's containerize it now. Okay, what I'm gonna do is simple. Do I scratch? No, crap. We're gonna have Docker file. Let's bring terminal here. I'm gonna have .NET SDK, installing PMNet 0.5, and have what on will be. I already have something existing, so I copy what I have for website.public. But of course, our stuff is not .public. It's called is demo. So I'm gonna have it. So yeah, stack, this plug, website, bang. And I guess the DLL will be that. Properties. Yeah, root namespace. Okay. Yeah. So let's do a Docker build simply to look at, okay, it's does it's buildable. And oh, I forgot something important here. We don't want the npm in this folder inside the container, so we have to add a Docker in your, because then the null module can be quite big. And I also don't want the app settings deployment.json inside my container that I will ship, I will publish. Why? Project file doesn't exist. Fine. Because it's not that. God. Okay. I'm gonna close that. I have a two folder structure, so it's not right. Let's delete that crap. Delete that crap too. I'm gonna put this inside this. Delete and delete. Okay. I'm bad at creating that project for the first time. So we have our now our Docker file is building. Let's run it from. Let's run it like a. Okay. So I'm gonna create a Docker compose file. The image will be expected KissOps demo. We're gonna run it on Power ADD. So what I simply have to do is Docker compose build. It's already created because we built it before, and the tingling image was there. So if I go localhost ADD, have it. I'm running it right now, locally. Okay. So one thing now we run our image locally. We are not still yet at the deployment stage, but we're gonna go there. To be able to deploy it, I'm gonna create a build push Docker file. And to be able to build it and push it inside the container registry from my GitOps action pipeline. I need to put inside my my application repository a file name called build push.docker file. I'm referring to it because the build is containerized too. We're gonna get that file, and then it will be used to build it and push it, because it's a base container, and the intention is to build the Docker file we have here, and then it will be pushed inside the container registry. So I have not other things to do outside creating the pipeline. So in GitHub, it's inside the folder GitHub under workflow. Okay, and I create a call. We call it CI.yaml, and I will start with just with the CI. Okay, so my CI will be quite simple. And I will add that git version.yaml. Okay. So from that point, I have everything I need. Oh, no, I don't have anything I need. I also need a git ignore. My intention here is not to show you how to configure the repo, but okay. So let's push it. Let's go on Docker Hub, GitHub. Oops. Oh god. Angular dot. Ah shit. Forgot to ignore that. Let's avoid that. Can avoid. Wait. My mistake. So yeah, during the time that it been pushed, we're gonna have the CD because the CI pipeline just build the Docker file directly. It doesn't pass it through the build push that Docker. So we're gonna add okay. So the CD gonna do what? Checked out, set up .NET on the agent, install Git version, determine the version, get the version inside the variables, do a Docker login. We're gonna I have to configure the repo to access the secret because right now it's not the case. Sorry. I'm gonna do the pipeline. Gonna do a Docker login first with the secret, and then we're gonna run the build push .docker file, and inside the build push .docker file, we the standardized way the standardized mechanisms will build the Docker file and push it directly to a Docker registry, and then we do a updated tag. Okay, sorry for that. I will simply leave. Sorry for that mistake. It happened. But inside it also the build push will the base container will also wrap out the chart required to run it on Kubernetes and publish it in the container the Elm registry. So we are not yet we didn't register the create the chart, so we're gonna do it too. We'll undo last minute. So what is the name I provide? Exploiter website. It will not be Exploiter website. It will be Exploiter KissOps demo. Okay, simple as that. And then now we're gonna create the chart. Gonna create a folder called Exploiter KissOps demo. In it, we define a file called chart. Chart.yaml with the chart KissOps demo. We keep it version and app version at 0.0 because it will be overwritten when we're gonna build it. Values, the YAML. Gonna create a file called services for the service that our application gonna have in Kubernetes. So there's no hard-coded value there, simply replacement variable references. And same for the deployment. The deployment might be a little bit different because we have okay, that's okay, and expector web new relic. So we have a reference to a config map called expector web dash new relic and email settings, but email setting we're gonna remove it because we don't have we need it. The site version environment variable, so don't mind too, but the new relic app name is important because when we're gonna deploy it, automatically the application will report metrics and instrumentation point to New Relic. So it's why inside the Docker file we have those values here, and right now the application, the .NET application doesn't have NuGet packages for this, so we're gonna add it. Rider. Yes, trusted. Sad. So as we see that our KissOps demo CI is there, but we still have issue with pushing the other stuff. Sorry, really sorry for that. So as you can see, we can quickly have a CI pipeline that build the application. It's working now. I will take some time to fix that weird push issue to the repo and get back to you. Ah, I see. Sure. I see. My bad. I did not put the feature slash, so that's why it was not showing up in the list. So we have the pipeline. And of course it's not running because I guess I don't have the permission to run it. I'll go inside my organization. Go there. Which secret I'm using? GC. Okay, and okay. C. Okay. I had to run on it because I allow the pipeline, the repo to be runnable for my private agent. So as you can see that we are building uh, the the container and plus the chart repo under the name extractor KissOps demo. So it's getting the core build vault where we store common secrets that are used then back for building and publishing the build artifact like the container images and the Helm chart repository, the Helm chart repo, the Helm chart artifact. Sorry, taking a while. And now it's building the container. Once it would be built, it would be pushed to the GitHub of my organization in GitHub container registry in my GitHub organization. Now it's pushing it. Push extractor KissOps demo under the version 0.0.1, I guess. Zero dot zero dot 0.1.0 alpha. Sorry. So it's push. Now for the Helm stuff, let me go there. See that we have the image. Okay. I will connect it to the repo. It simply it doesn't have value outside that. When I go on the repo, I have a link direct to it. Okay. So the build doesn't work. Publish doesn't work because of the chart doesn't exist. I did a mistake here. The chart is expected to be under /chart, and I directly put it inside the wrong folder. So chart. Fixed CD. So we're gonna wait a little bit more. The CI and the CD pipeline started at the same time because I have triggers on it. But normally I don't have the triggers on the feature branch for the CD. I have it only on the main or master branch, and then I keep the capability to trigger it manually when I need from the release branch. But yeah, so right now, because it's the first time we create the Git repository and we need to use the CD for the demo. That's why we have it both at the same time. And then when we're gonna when it will be deployed officially on the dev cluster, we're gonna see in APM and service in Neuralink, we're gonna see it one another one like dev dot KissOps dev demo available here. So we see that the dev Explorer website is now reporting metrics. Not 7 demo, maybe 30 minutes since the last hour, I guess. You see that now it's reporting back information. Okay, it's calling the Helm repo. And over here, it's on the Helm. It's been updated. Can we see that we got the KissOps demo. So now it can be possible. We are able to publish our application inside Kubernetes, but we need a change. Why? Because our deployment and chart doesn't include the application and chart, which is so because mchart is like NuGet packages. You have a NuGet package that reference other NuGet packages, and charts work the same way. You can reference in your Helm chart another Helm chart. It's a package management stuff. So I'm gonna create a branch features KissOps demo. And then I will do what? I will use I will open up with the VS Code because 4 days ago, why I open up it's weird. It's really weird. Okay. I did stupid thing today. New branch. Its features get up to the okay, it's okay. Features get up the sorry. Okay. So what I need to do is, in order to be able to deploy it, I need to change a little bit more my chart. Okay. So I have to include the reference to my Helm chart that we just created, and I need to also give the version number that I want at minimal. So we still at the stage that we have a version 0 dot something. So it took everything greater than 0 dot something. So we have a version 0.1. So yeah, and the other application is at version 1.9. So it's why it's greater than 1.9. And inside the inside the value.dev, inside the value.dev, Experta website need, I put intentionally a number of replicas. So we will do the same because inside the deployment we control how the application gonna be deployed. So let's keep it at 1. Okay, and we will look at something interesting over here about Helm. How we gonna know how that value we're gonna be inject inside inside the other chart in a reference. It's simple. Value.replica comes, so I don't have to hard code the reference to Experta KissOps demo.value.replica counts. No. The way it works with Helm, it's because I reference another chart under the name Experta KissOps demo, and because my chart name is Experta KissOps demo, it knows that that value would take part of value.replica counts. It's the way it works. So now we're gonna have that first, then we're gonna create the reference for the DNS. So include the KissOps demo. And then it will start being built, but we're gonna deploy it. I will minimize that one, and we're gonna wait until it's deployed. So we can scale it down. Okay, now we're gonna deploy it in there. The beauty of this is we had a new application which deliver new business value, but we didn't touch Experta website. We had Experta KissOps demos website. So when we deployed that, because we didn't touch Experta website, in Kubernetes, Experta website will not be updated. It's still the same website with the same version, with the same code. So we don't touch that one. It will not be restart. It will not be destroyed. It will be keep running. But the deployment will have Experta Kiss ops demo. And the build works. So that means the the new dependency chart has been added, as we see here. So let's wait again. So as you can see here, Kiss demo just been added. I will right now we are not able to access it because there's no ingress rule that has been configured to go there. If I look at the ingresses, backend services, what I configure for that, I keep it. Frankly, I keep it. I keep it simple for the website, so that's why it's quite a little bit more complicated to change. But so now it's deployed. So to have something point out to demo that dev.expector solution, I need to dig a little bit more because my ingress mechanism is a little bit too much simple and it doesn't have been made to be to have more than one service. Okay. what I will do, I will simply overtap ingress. I don't want to put the path. Okay. Okay, what I will do? I will do that. I'm gonna link that one there. It's not this. Not this. I'm gonna do that. So we're gonna have domain emo.delta.solution.com secret. I'm gonna do that, and inside ingress range domain. Okay, so it's not gonna try that. Might not work, but let's for it. No, so let's for it. Keep it there. So we're gonna point out demo.dev.expertosolution.com to KissOps demo, but the rest will remain on the website. So what I change, it's the way we allocate, we configure the service name, because the service name was under in value.ingress.backend, but I put it under domain, so it's at the same level, so I have to simply say service name. And in the script we need to add the demo part, so I simply add demo configure for public access. Because if I go on demo.dev.expertosolution.com, I have nothing. Okay. And if I go on dev.expertosolution.com, then I have something. But having during the time we wait for the build and the release, we can look at the New Relic, because Experto KissOps demo is there. Is actually right now in my dev Kubernetes cluster. So if I go in APM and services of my Kubernetes of my New Relic stuff, we're gonna see that. You see, dev.expert.kissdemo showed up. And from that point, now, because I operationalize all the platform and I have alerts, I could receive alerts came out from that application. By example, if the CPU usage or memory usage goes too far, I will receive alerts. So from that point, my application is still covered by the operationalization encapsulation of my platform. So I don't have to worry about that. I can go inside the logs, and I can see I capture logs from my app. Okay. Of course, I don't have right now access outside the health and readiness health check, but unfortunately, I did not add it in the code. So even if my application here in the definition had liveness and readiness to configure on the elements, the endpoint doesn't. Those endpoint doesn't exist in my app right now. I did not add it intentionally, but being under KissOps means being operationalized means having every application reporting having health check endpoint. Okay, I guess I can deploy it now. And the other elements we didn't speak about, it's the certificate that we can see that the certificate is there. Okay, it's part of my deployment. So now it's running. To also to add the domain name, I simply add demo because it's an array of string. I loop over it and I point out to the IP address used by that and by that application. So it's getting back. It's getting secret now. Corp, because it's getting environment secret and then corp secret. And now it's deploying back. It's deploying back the application, but because it's already been deployed at the version. Whoops, sorry. At the version 0.1.0-alpha, Kubernetes and IAM doesn't have to reschedule the creation of the container. But what it did, we created the demo -dev and it's been pointed out to the public IP. So normally if I hit refresh, you see now my new website is up. I did not change so many things. It's quite quick, and also it's reporting in Kubernetes in New Relic, which is my EPM management platform. Simple as that. The other things I'm gonna do, but I think I will do it in another session, which is how easy it is to switch over from one cluster to another, because I can destroy a new my current dev cluster, recreate it, and then have it back up alive in dev or in prod. But I will keep it for another session. So thank you for your time. I hope it helps. For sure, the discussion around KissOps can go far than those 2 hours session. I guess I'm speaking since 2 hours, but I know it goes far over the current session of today. If you have any question, don't hesitate to contact me. It's always a pleasure to share about experience